Welcome friends. Today we are going to discuss about the calculation of drainage density using quantum GIS software. So friends, we required two layers for the computation of drainage density in this software. First one is the drainage layer. That is very much important because without that we cannot compute drainage density. And next one is the watershed boundary or basin boundary. So we have already added here this two layers. So for computation of drainage density, go for this vector layer menu, select this research tool, and within that research tool there is a create grid extent. So I have selected this one, and within that you have to select this rectangular polygon grid because we require polygon grid. Then we have to assign the extent of the grid creation. So I have this watershed boundary, I have selected this one. Then we need to specify horizontal and vertical spacing. And as we know that drainage density is nothing but the stream length per unit area. So unit area is 1 kilometer by 1 kilometer grid. So that's why I have selected here kilometer and here is the 1. Okay, then it will go in a temporary layer. It is created. Okay, then after that we need to compute this length, stream length, within that each and individual grid. So we have this option in a vector layer. There is a option that is analysis tools, and within that analysis tools we have to select this sum line length tool. So what it will do the sum of the length of particular lines within that selected grid. So here we have selected grid as a polygon extent, and we have selected here line as a drainage line extent. Okay, then see, lines length field name is the length and lines count field name is the count. So it will gives us length within the square grids of 1 kilometer by 1 kilometer, and also it provides the count or number of streams within that grids. Just you have to click here the run option. Let us see the attribute table of this sum line and length temporary folder. Look at that. This is the length. It means that in this particular grid we have 768 meter of 768 meter upstream length and count is 1. So as this way we are having this length and counts. So let me put it over this grid. Then after that we have to convert these grids or line length grids into the raster format. So for that we are doing this process. Within this raster there is a rasterization tool in which it is converted vector layer into the raster format. So input layer we have selected as a line length, and filled that we required is the length. So we are having this length as a in field which we are going to convert into the raster format. So here, not okay, then we have to specify the resolution of the square, mm, the resolution of the raster which is going to be created. So I have selected here 1000 because we are dealing with the 1000 meter by 1000 meter grid, and here you need to select the output extent. Within that output extent it will be created. Okay, missing parameter value, output raster size. Okay, we have to resolution, output raster size. Eh, Here I have to select the pixels, then it will run. Close. So look at that, just do little bit symbology, classify, and then apply. So friends, as this way we could compute the drainage density of a particular watershed or basin by using this quantum GIS software. Thank you.